here's a little video on how to do a Boyles Law calculation. In this particular case, I am looking to find P2. I have P1, V1, and V2. And here's my equation, so I need to solve it for P2, which means I would divide both sides by V2. And I would get that P1, V1 over V2 equals P2. And I'm ready now to substitute in. P1 is here at 327 kilopascals. V1 is 93.9 milliliters. V2 is 129.9 milliliters. And my units, milliliters, are going to cancel out. My answer is going to come out in kilopascals, which is good. That's a pressure unit, so that works. And now on my calculator, I'm ready to put in 327 times 93.9 divided by 129.9 equals, and I get 236.37. And looking here, I have three significant figures, 3 and 4, so my answer can only have 3. I will be keeping this much of my number. The ones place is the last digit I can keep. The tenths tell me to round off, so it would be 236 kilopascals. And that's my final answer. This would work exactly the same if I had, let's say, a volume but not a pressure 2. So if I had for pressure 1 is 93.7 kilopascals, volume 1 is 5.01 liters, volume 2 is my unknown, and pressure 2 is, let's say, 393 kilopascals. So again, P1, V1 equals P2, V2. Solving for V2, I get P1, V1 over P2 equals V2. And so for P1, I'm going to put in 93.7 kilopascals. For V1, I'm going to put in 5.01 liters. For P2, I'm going to put in 393 kilopascals. Kilopascals cancel. I'm ready now to get out my calculator. And I'm going to put in 93.7 times 5.01 divided by 393 equals 1.194, and that unit is going to be liters. And now I look at my significant figures, and I have 3 here, 3 here, and 3 here, so my answer will have 3, so that's 1, 2, 3. 4 says I just round it off, and I get 1.19 liters. So, let me know if you have any questions. I should have this posted in just a minute. Thanks.